Richard, live na po ulit tayo.
Okay po. Sir, padinig din po nung isisingit na trade na teleradyo Marcelo para alam ko po kung saan po ako mag-hello everyone.
Ay, hindi na. Hindi na.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo kahit magkalayo sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.
Grade 8 students, hindi nyo ba maintindihan ang math lesson sa linggong ito? Hirap intindihin ang basic postulates o theorems sa geometry. Sagot ko, ang problema nyo. Kaya ano pang hinihintay nyo? Mga batang malulenyo, tara, mag-aral tayo dito sa Teleradyo Marcelo.
Makinig, manood na sa teleradyo. Makinig, teleradyo Marcelo.
Hello and good morning, Delpilarians, and as well as Maluleños. Welcome to the Quarter 3, Week 3 Teleradyo Marcelo episode of Mathematics 8, ang telearalan ng bawat Maluleño. This episode is made possible by the Teleradyo Marcelo team and Junior High School Mathematics Department. I am Mr. Richard M. Cruz, your Mathematics 8 teacher broadcaster. For today's episode, we will discuss Quarter 3, Week 2, entitled Mathematical System, Basic Postulates and Theorems, as well as the Triangle Congruence for Quarter 3, Week 3. So, we would like to get the attention of the grade 8 students, especially those who experience difficulties in the lesson. Throughout the episode, we will describe the mathematical system and illustrate the need for an axiomatic structure of the mathematical system in general and in geometry in particular. With that, we will use the defined and undefined terms as well as the postulates and theorems that were discussed by Ma'am Charito Ferrer from the previous Teleradyo episode. You will also be able to identify properties and illustrate two congruent triangles. So, bring out your paper, pencil, and snacks. Take your most comfortable seat and let's get started. Let's take a quick review of our previous lessons by answering this crossword puzzle. Take a screenshot of this slide and try it yourself. Post your answers on the comment box with your full name and section. Number 1, across. Points that lie on the same plane. Number 3, contains at least 3 distinct non-collinear points. Number 4, part of a line with 2 endpoints. Number 5, part of a line with 1 endpoint. Down, number 1, points that lie on the same line. Number 2, the intersection between 2 planes. Good luck! These are the correct answers. Number 1, coplanar or coplanar. These are points that lie on the same plane. That's the clue. Plane, coplanar or coplanar. Number 3, plane. It contains at least 3 distinct non-collinear points. It means that we can have more than 3 points in a plane. Next, segment. That is a part of a line with 2 endpoints. A ray has 1 endpoint and 1 arrow. Take note of that. And that's number 5, ray. For number 1, down, collinear is the term describing the points that lie on the same line. Collinear, that's our clue, collinear line. And number 2, the intersection between 2 planes. That is a line. Great job! Those words are essential in understanding our topic later. As you have noticed, our lesson for the 3rd quarter are beyond solutions, finding the value of x, solving for an unknown variable in an equation or inequality, and using plus, minus, times, and divide, which are essential operations. However, we are challenged to think deeper and imagine things that can only be represented by simple objects around us. With that, warm up your brain cells with this challenge. So here's the question. How many squares are in this picture? Post your answers on the comment box with your full name and section. Afterwards, your mathematics teachers will check your answer. Timer starts now. Great job. Let me see your comments on the Facebook. From Princess Althea Valdez of grade 8, section 1. Her answer is 40. Very good. That's the correct answer. And I think that's a great warm-up. It's a sign that we are now prepared for the next challenges. During the discussion, your active participation is highly encouraged by writing your answers on the comment box. We discourage commenting unnecessary words or phrases that are not related to the subject. So let's proceed and make this learning fun and easy. To give you a glimpse of our learning journey, here are the questions for your guide. Number 1. What are the different postulates involving point, line, and plane. Second, are all right angles equal? Why? Third, how do we illustrate segment and angle addition postulates? Number 4, can we express distance as a negative number? Why? Why not? Number 5, if the two triangles have the same sides, are they congruent? Number 6, if the two angles have the same, or if the two triangles have the same angles, are they congruent? Number 7, what is an included side or included angle? Let's begin with the basic postulates and theorems. To start, we have the line postulate. Imagine points A and B connected. There are no other lines that can connect those points. This time, it is only line M that contains points A and B, not line X, nor line Y, nor line Z as illustrated. Therefore, the line postulate states that for every 2 points, there is exactly one line that contains both points. Did you get that? That's the line postulate. Next, the plane postulate. Let's say we have points A, B, and C. Isn't it that if we connect those lines, we can create a shape? Correct, that's a triangle. But outside those points, we can imagine a plane. Let's say it's plane M. And plane postulate states that any 3 non-collinear points lie in exactly one plane. Or any 3 points are always coplanar. Imagine you have a typewriting, a short bond paper, or an A4 size paper. And you put 3 dots. You name them point A, point B, and point C. Isn't it that those 3 points are drawn in that typewriting or bond paper? That's the plane postulate representation. Next, the flat plane postulate. Can you imagine points A and B drawn by a line, and that's inside plane M? The flat plane postulate states that if 2 points of a line lie on the plane, then the line lie on the same plane. It's as easy as that, drawing a line with points on a bond paper or on a clean piece of paper. That's a representation of the flat plane postulate. Both the points and the line is contained inside that plane. Next, let us have plane P and plane M crossed together. Afterwards, we may observe, or we can notice, and we may show it's shown that there is a line intersect on the intersection. That's line X on our example. It states that if 2 different planes intersect, then their intersection is a line. For additional postulates, a line contains at least 2 points. What does it mean? Let's say we have a line with points A and B. That's enough to describe a line. But we can also show some other or more than 2 points. Let's say we have points C, D, E, F, G, and H, and more contained on that line. The additional postulate number 2 states that a plane contains at least three distinct non-collinear points. Do you remember the definition of non-collinear or collinear on our warm-up? It can be illustrated by a plane M and showing three non-collinear points. It means that points A, B, and C are not lying on on a single line. When we say it contains at least three distinct non-collinear points, we can show more than 3 points. Point D, point E, point F, G, H, I, and more. That's the additional postulate. The third additional postulate states that a space contains at least four non-coplanar points. Imagine this space represented by a rectangular prism in green. That's three-dimensional. And we can identify or show four scattered points, not lying on the same line and not lying on the same plane. We can also have more than 4 points. Point E, point F, point G, H, I, and more scattered on plane or on that space. That's the additional postulate. How about three basic theorems using those point, line, and plane? Imagine line M and line X. Isn't it that there is an intersection or point of intersection? By this time, our example is point A. It states that if two lines intersect, then they intersect at exactly 1 point. No more, no less, only 1 point. And intersecting lines plane theorem, which is our basic theorem number 2, states that if we have two intersecting lines, it is contained on one plane. Or if two lines intersect, then exactly one plane contains them. Can you imagine drawing two lines or two intersecting lines on a bond paper or on a piece of paper? That's the representation of theorem number 2. How about the third theorem, the line point plane theorem? Imagine line M and line F not containing on line M. You can draw that on a piece of paper represented or on plane R. It states that if there is a line and the point not on the line, then there is exactly one plane that contains them. How about the line-plane intersection theorem? Can you imagine a piece of paper and you poke that with a wire? That's our theorem. That's the representation of our theorem. Let's say we have here, for example, plane R and a line X intersect that plane. You may notice that there is point F of intersection. Or the theorem states that if a line intersects the plane not containing it, then the intersection contains only 1 point. Now, those 11 statements are the basic postulates and theorems that involves points, lines, planes, and even space. And to test your comprehension, let's try answering these questions. Feel free to answer each question. Please don't forget to indicate the number or numbers for each answer, as well as your full name and section, so that your respective math teacher will acknowledge your comment. Good luck! That's 30 seconds. Did you have your answer for numbers 1, 2, 3, 4, and 5 questions? Let's have more. Another 30 seconds have left. Those are the questions for numbers 6, 7, 8, 9, and 10. So let's go back to the following questions and read those comments on Facebook. The first comment is from Kian Gabriel Elardo from grade 8/3. Her answer or his answer is number 1, 2 points. Let's see if that's correct. Very good, Kian. Princess Althea also got the correct answer, but it needs the undefined term point. Princess Althea Valdez, Gian Marco Clutario, Roy Carmela Cua, Renia Joy de la Cruz, Maricel Bartolome, Erwin Fabian, Jasmine Mariel Garcia, Leila Gianna Caluag, Marico Benaventura, Angel Joy Panganiban, Rian Martin, Kevin Jan de Leon, Cyron Dale Campana, Isel Daphne Avendaño. And from Jan Loren de Guzman, from grade 8/1, for number 2, 3 points. Let's see if your answer is correct. Correct, 3 points. Great job. Most of you got the correct answer. Let's see. For number 3, how many planes can contain a line and a point not on a line? Who got the correct answer? Correct, 1 plane. Maria Charlene Estrella from grade 8/2 got the correct answer. And some of the students also got the correct answer. Congratulations. How about number 4? At least how many non-coplanar points are contained in a space? The answer is 4 points. Number 5, how many planes can contain 3 non-collinear points? Your answer is correct, 1 plane. How about number 6 to 10? Number 6, the correct answer is line. Number 7, what contains at least 2 points? That's also a line. Number 8, what contains a line and a point not on the line? Correct, that's plane. What contains at least 2 distinct intersecting lines? Very good. That is a plane. And what can contain at least 4 non-coplanar points? Did you get the correct answer? Space. What is your score? Did you get all 10 answers correct? Great job. Let's continue the discussion with different postulates and theorems that involves measurement of distance and angles. For example, we have angle X that measures 90 degrees, as well as angle Y measuring also 90 degrees. They are both equal, so we can say the measure of angle X is equal to the measure of angle Y. Therefore, if they have the same measure or equal measure, we can say that angle X is congruent to angle Y. Or the right angle postulate states that all right angles are equal and congruent since they have 90 degrees as a measurement. Now, it doesn't matter which one leans to the left or which of the angle leans to the right or which one has a longer ray. It doesn't matter. We are only considering the angle which are equal to 90 degrees. That's the right angle postulate. How about the distance postulate? Can you imagine a line with points M, H, and P? We can measure that the line between or the segment between points M and H is equal to 5 units. And for example, the segment from point H to point P is equal to 38 units. The line postulates, the distance postulate states that for every pair of points, there corresponds a unique positive number. Positive number, not negative. This positive number is the distance between 2 points. Or we can also use the distance formula. Or when we say distance, we are talking about the absolute values, which are neither positive nor negative. The segment addition postulate states that if H is between M and P, then MH, which is equal to 5 units, and HP, which is equal to 38 units, is equal to a total of 43 units, which is also the distance from point M to point P, or segment MP is equal to 43 units. Do you remember the integers on a coordinate? That's it. Have you noticed we have 0 in the middle? The positive numbers are 1, 2, and 3. And have you seen those red integers are all negative? Correct. You learned that during your grade 7. The ruler postulate states that for every point on a line, or every point on a line can be paired with a real number. Yes, those are the real numbers, negative 3, negative 2, negative 1, 0, 1, 2, and 3. The angle addition postulate can be shown on this example. Let's say we have angle MXP, and a ray inside is ray XO. It states that if the measure of angle MXO plus the measure of angle OXP is measured, that is a total of the measure of angle MXP. Let's have an example. Suppose that the measure of angle MXO is equal to 85 degrees plus the measure of angle OXP is equal to 65 degrees. We can have this equation. 85 plus 65 is equal to the measure of angle MXP. Then, what is the measure of angle MXP? That's 85 plus 65. Please do not use your calculator. That's a total of 150 degrees. And the angle addition postulate states that if O, or point O, is in the interior of angle MXP, then the measure of angle MXO, which is by this time, our example is 85 degrees, and plus the measure of angle OXP, by this time, our example measures 65 degrees. That is equal to the measure of angle MXP, which is equal to a total of 150 degrees. Did you use a calculator? You can add 85 and 65 mentally. Okay, that's 80 plus 60 and another 10. That's 150. Do not use your calculator. The triangle angle sum theorem can be shown on this example or in this equation. Let's say we have a triangle with, or the triangle XYZ. the measure of angle x plus the measure of angle y plus the measure of angle z, which are the interior angles, are all equal to 180 degrees. No more, no less. That's 180 degrees. You can prove that yourself. In every triangle, the sum of the measures of the interior angles is equal to 180 degrees. Please don't forget, 180 degrees. No more, no less. We're done illustrating and describing basic postulates and theorems in the mathematical system and in geometry, to be specific. Maybe you have some postulates or theorems that aren't clear for you. Don't worry. The Teleradio team will upload this episode on Facebook and YouTube. So don't forget to follow and subscribe on our social media platforms. No available resources for our social media platforms. Your respective mathematics teachers got you. We have Ma'am Emma Garcia, Ma'am Pearl Laksa, Ma'am Charito Ferrer, Ma'am Chelsea De Luna, Sir Emer Narciso, Ma'am Lani Riopirio, and of course, yours truly, Sir Richard Cruz, to entertain your questions through Messenger or SMS. So let's apply those basic postulates and theorems in proving some other theorems. This is also your chance to comment your answers so that your teacher will acknowledge your presence and participation. We have the linear pair theorem. It states that if two angles form a linear pair, then they are supplementary. Let's have an example to prove this theorem. We were given angle AOB and angle BOC form a linear pair. Have you seen that figure? Let us prove that angle AOB and angle BOC are supplementary. What do you mean by supplementary? Is it a total of 90 degrees or a total of 180 degrees? Correct. When we say supplementary, that's a total of 180 degrees, or two angles measuring a total of 180 degrees. How about complementary? When we say complementary, two angles measures a total of 90 degrees. No more, no less, 90 degrees and 180 degrees. Those are complementary angles and supplementary angles respectively. So let us prove. Again, we were given that angle AOB and angle BOC form a linear pair. And let us prove that angle AOB and angle BOC are supplementary. For these two-column proving, we will start with the basic definitions, postulates, or properties that were learned on the previous weeks. And to make sure that we have the correct proving, the last statement and the last reason must prove our statement. What's our first statement? Angle AOB and angle BOC are linear pair. For what reason? Did you say given? That's correct. How about statement number 2? Ray OA and ray OC are opposite rays. What do you think is the reason? Can you recall a definition from our previous weeks or lessons? Correct. That's the linear pair definition. The linear pair definition states that if ray OA and ray OC are opposite rays and ray OB is another ray, therefore, we may conclude that angle AOB and angle BOC form a linear pair. Or have you observed or have you noticed that line AC is a straight line? That's the clue for the linear pair definition. And the third statement states that the measure of angle AOC is equal to 180 degrees. What's the reason? Yes, that's the definition of straight angle. And the straight angle definition states that if an angle is considered a straight angle, then it measures 180 degrees. Third statement, the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. What is the reason? Yes, that's the angle addition postulate that we have learned earlier. The angle addition postulate states that if B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. And those angle measures are all equal to 180 degrees. Why? Correct, that's the substitution property of equality. And the substitution property of equality gives us the property of replacing. By this time, it's the measure of angle AOC with 180 degrees. Have you seen the previous statement? They are almost the same. And we just replaced the measure of angle AOC into 180 degrees from the third statement. And the last one, angle AOB and angle BOC are supplementary because of the definition of supplementary angles. And it states that, for example, the measure of angle AOB is equal to 110 degrees, and the measure of angle BOC is equal to 70 degrees. Okay, that's the definition of supplementary angles. Now, we have proven that angle AOB, angle BOC are supplementary. Next, let us have the supplement theorem. It states that if two angles are supplementary to the same angle, then they are congruent. We were given angle 1 and angle 2, which are supplementary. Also, angle 3 and angle 2 are supplementary. Let us prove that angle 1 is congruent to angle 3. The first statement is angle 1 and angle 2, as well as angle 3 and angle 2 are supplementary. What's the reason? Yes, that's given. Second statement, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. What do you think is the reason? Yes, that's the definition of supplementary angles. If two angles are equal to 180 degrees or a total of 180 degrees, correct. That's definition of supplementary angles. Let's say, for example, the measure of angle 1 is equal to 40 degrees and the measure of angle 2 is equal to 140 degrees. And the measure of angle 3 is also equal to 40 degrees. Isn't it that when we add angle 1 and angle 2 measures, that's a total of 40 plus 140, 180, as well as adding angle 2, which measures 140, and angle 3, which measures 40, is equal to 180 degrees. Yes, that's the definition of supplementary angles. Now, the third statement, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. What do you think is the reason? Can you recall a property of equality that were discussed? Yes, that's the transitive property of equality. That property of equality can give us the reason that copying one side of each equation and creating a new equation Have you noticed our statement number 2? Yes, we used measure of angle 1 plus measure of angle 2 and measure of angle 3 plus measure of angle 2, which are both equal to 180 degrees by transitive property of equality. Now, have you noticed our statement number 4? That's measure of angle 1 is equal to measure of angle 3. What is the reason? Yes, that's another property of equality. And we call that as the subtraction property of equality. The measure of angle 2 is common on each side of the equation. So we can remove measure of angle 2. And what's left? Measure of angle 1 is equal to measure of angle 3. And the last one, we can say that angle 1 is congruent to angle 3 by definition of congruent angles. We already proven that the measure of angle 1 is equal to the measure of angle 3. Then the last statement will give us that the measure of angle 1 or angle 1 is congruent to angle 3 by definition of congruent angles. Now, we already proved that angle 1 is congruent to angle 3. Those were the two basic examples of proving theorems using definitions, properties, postulates, and basic theorems. Hope you already recalled those statements to help you answer this proving activity. We were given vertical angles theorem, and it states that if two angles are vertical angles, then they are congruent. We were given that figure, and angle 1 and angle 3 are vertical angles formed by intersecting lines R and S. Let us prove that angle 1 is congruent to angle 3. I will give you the statements, 4 statements, and you please give me the 4 reasons. Please don't forget to write the answer with each respective number, as well as your name and section, so that your mathematics teacher will acknowledge your participation. I will give you 60 seconds. That's it. 60 seconds have left. That's 1 minute. Let me check your comments on our Facebook Live. Okay, we have comments from Cyril Komatsu. Number 1, given. Correct. Also from Leila Gianna Di Caluag, Ana Katrina Kapulong from 8A SPA1, and Andrea Golpan from 8 SPA2, as well as Andre Alfaro Martel from grade 8/3, Renia Joy de la Cruz from grade 8/2, Christoph Benedict Ilagan from 8 Gomez, Ralph Nathan Mansilungan from grade 8/1, John Marco Clutario, Janelle Carpio, Lizelle de la Cruz, Jovel Handonero, Luis Gabriel Dorado Cardozo from Grade 8 SPA 3, Rayan Martin from Jonah Cruz, from Eric Abelong, Joyce Malyari, Yesamin Ambrosio, Hannah Graciela Segura, Precious Marine, Hale Avila, Kent Irvin Acuyong, and Shilin Silverio, Rachel Ann Reyes, Kenneth Bautista. Okay. Don't worry if your name has not been you did not hear your name. Your mathematics teacher always acknowledges you. Okay. So that's the correct answer, as well as number 2 that is also given. How about number 3? Okay. Number 3 from Anik Beatriz Marasigan. Your answer is linear pair theorem. Very good. Also from Suzanne Pascual, Cyril Komatsu, Yesamin Ambrosio, Luis Gabriel Cardozo, Jan Loren de Guzman, Rachel Paglia. How about reason for statement number 4? Correct, that's the supplement theorem. From Joyce Malyari, Acel Daphne Avendano, Yesamin Ambrosio, Vincent Maren Magsakay, Camille Hazel Antenco, Denise Salandan, Venus Duarte, Cyron Dale Campana, Angelo Lidon Lagi, Angel Nicole Carlos, Janelle Carpio, Mark Frondozo. All your answers are correct. So let us recall the previous proving. The linear pair states that if two angles form a linear pair, then they are supplementary. And the supplement theorem, if two angles are supplementary to the same angle, then they are congruent. Great job, guys. Now you can prove some other theorems. Do you know what congruent triangles are? How do we say that two triangles are congruent? Let's explore this topic. How do we say that two triangles are congruent? They should have equal sides and equal angles. Let's say, for example, we have triangle A, B, and C in blue, and triangle X, Y, Z in green. Let's say, for example, side CB is equal to 7 centimeters, and side ZY is also equal to 7 centimeters. Have you noticed? I put a mark on each side because they are equal. One mark, as it tells that that is the shortest side. And 9 centimeters for both sides AC and XZ. We can also have markings. By this time, two lines on each, considering that they have the same measure, as well as our hypotenuse. That's 11.4 on sides AB and XY on each triangle. Yes, we can put 3 markings on each side, telling us that that is the longest side. Isn't it that the hypotenuse has the longest side of a triangle having 90 degrees? Correct. Now, they have equal sides. How about the angles? Angle A is equal to 38 degrees, which is also equal to the measure of angle X. Yes, we can also put markings on those angles. And 52 degrees is the measure of angle B, and angle Y. Yes, we can also put markings, two markings for those angles. And that's a 90-degree angle on each corner. We can put a drawing similar to a small square because that represents 90 degrees and they are both equal. We already proven that two right angles are always equal. Now, we already proved that those angles are all equal. Having equal sides and equal angles, we can say that these two triangles are congruent. We can also write that triangle ABC is congruent to triangle XYZ. Okay, that's our notation for triangle and congruency. Have you noticed letter A and letter X, letter B and letter Y, as well as letter C and letter Z? They have similar positions on each triangle. That's very important because we want to tell corresponding angles and corresponding sides. For example, we can say that angle A corresponds angle X. That's the notation on the right. Similar to a line having two arrows. And side AB corresponds side XY. Let me test your eyes with this activity. Let us identify the triangles congruent to triangle ABC. 30 seconds. That's 30 seconds. Now, have you seen or have you noticed triangle ABC is also congruent to triangle DEF? There you go. By sliding triangle ABC, that is also congruent to triangle DEF. By sliding or slit. Next, we can have the notation triangle ABC is congruent to triangle DEF. Another triangle? Yes, triangle GHI is also congruent to triangle ABC. How about turning the triangle ABC into 90 degrees? Yes, we have that triangle GHI congruent to triangle ABC by turning. And we can have the notation triangle ABC is congruent to triangle GHI. Last one. Yes, we have triangle JKL. By flipping triangle ABC horizontally, we have triangle JKL congruent to triangle ABC. How about triangle PQR and triangle MNO? They are resized. We cannot say that they are congruent. Although they have equal angles or interior angles, but the measures of their sides are not equal. Triangle PQR may be the smaller version of triangle ABC, and triangle MNO is the larger version of triangle ABC. We can only say that they are similar, not congruent. There you go. Now, we can define that congruent triangles are two triangles are congruent if and only if their vertices can be paired so that corresponding sides and congruents are congruent and corresponding angles are congruent. Again, congruent triangle, the definition, two triangles are congruent if and only if their vertices can be paired so that corresponding sides are congruent and corresponding angles are congruent. Please don't forget corresponding and congruent. Now, how do we define congruent angles? That's our definition. Do you want to check if you fully understand triangle congruence? Try this activity. Identify the following statements are as true or false by putting a check mark or an X on each box. We have triangle PQR and triangle JKL. There you go. Let's see if you have the correct answers. We have the following true statements. Angle P is congruent to angle J. Side JK is congruent to side PQ. Triangle PQR is congruent to triangle JKL. Or we can also say that triangle RPQ is congruent to triangle LJK, considering their corresponding parts. When dealing with parts of a triangle, there are angles and sides that are in between parts. Let's take a quick discussion on included side and angle. When we say included side, there is a side common to two angles of a triangle. For example, we have triangle STU, considering angle XS and angle T. Our included side is side ST. Yes, we only use the letters of those two angles, S and T, to represent the included side ST. As easy as that. How about an included angle? That is an angle between two sides of a triangle. For example, we have VWX as the triangle. And considering side XV and WX, or side VX and side WX. Yes, our included angle is angle X. Now, that's an episode full of learning. You are ready to answer the assessment part of your module. Do you have questions, ideas, suggestions, or clarifications in mind? Please do not hesitate to contact your Math 8 teacher. I would like to take this opportunity to thank our ever-youthful Dr. Vivo, the principal of Marcelo H. Del Pilar National High School. Of course, the assistant principals, especially our department head, who never get tired, Sir Marco Eusebio, and as well as Ma'am Donna Estacio. Also to my colleagues from the Junior High School Mathematics Department, who are now watching with us. Thank you. And of course, this Teleradio episode will never be possible without the technical working group, Ma'am Hilda, Ma'am Bernadette, Ma'am Isabel, Sir Pawi, and Sir Frederick. Mabuhay po kayo. Maraming salamat po. I am Sir Richard, your Mathematics 8 teacher, broadcaster for this week, na nagpapaalala mula sa Love Radio. Una, magdasal ka para mabuhay ka. Pangalawa, mag-face mask ka para mabuhay naman ng iba. Yon! Again, this is Sir Richard, now signing off. Maraming salamat.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo kahit magkalayo sa programang ito. Tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo.